Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm a senior contributing editor with Data Science Central and also chief data scientist for Data Magnum. I'd like to start off our event today by thanking Teradata and Hortonworks for sponsoring today's event. Both companies are wonderful supporters of Data Science Central community, and we're honored to have them sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Pivotal, Microsoft, Tableau, Oracle, IBM, and Cisco, to name just a few. Our past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of current interest to our data science community. Today's webinar is entitled Deriving Analytic Insights from Machine Data and IoT Sensors. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be 1 hour long. We have two panelists that I'll introduce in just a minute. There will be 10 or 15 minutes of Q&A following the presentation, and this event is being recorded and will be available on datasciencecentral.com in the next few days following today's live event. I'd also like to encourage our attendees to provide questions throughout the presentation. We'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. I'm very pleased to introduce today's speakers, Chad Meley of Teradata and John Kreisa of Hortonworks. Chad is Vice President of Product and Services at Teradata. He's held a variety of leadership roles in data warehousing, business intelligence, marketing analysis, and CRM. Chad holds a BA in economics from the University of Texas, an MBA from Texas Tech University, and performed postgrad work at the Red McComb School of Business at the University of Texas. John is Vice President of Marketing Strategy at Hortonworks. Previously, he was a director at Red Hat and Vice President at Cloudera. John holds a BS in Computer Science from the University of Texas at Austin. Thanks for being with us today. We're looking forward to your presentation. So today, Hadoop and the Internet of Things has enabled data-driven companies to leverage new data sources and apply new analytical techniques in creative ways that provide competitive advantage. Beyond clickstream data, companies are finding transformational insights stemming from machine data and telemetry that are radically improving operational efficiencies and yielding new, actionable customer insights. In today's webinar, we'll discuss real-world case studies from the field that describe the strategies, architectures, and results from forward-thinking Fortune 500 organizations across a variety of verticals, including insurance, healthcare, media and entertainment, communications, and manufacturing. John, Chad, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thanks very much, Bill, and good afternoon, good evening, and welcome everybody. On behalf of Chad and myself, we're very happy to have you here today on the webinar. What Chad and I are going to do, as Bill mentioned, is talk about some transformational case studies in machine data and telemetry. The explosion of data sources and types from machines that are helping organizations across a very wide range of industries is really driving transformational use cases, really driving businesses to new forms of efficiencies, to find new ways to optimize their business. And Chad and I are definitely going to spend some time talking with you about that. What I want to do is I want to start with a little bit of context around data. Data really is at the heart of what's driving this change, and certainly the form of data, the kinds of data that organizations are collecting has changed. And today, 90% of the world's data that was created in the last 2 years, meaning the rate at which data is being created by machines is accelerating, and that data has tremendous potential for organizations. We'll talk a little bit more about the potential in just a second. Now, most of that data, unlike in the past, most of that data, more than 80%, is unstructured data, meaning it doesn't really fit neatly into kind of traditional systems. So really organizations are looking for a way to capture a lot of these new forms of data. They come in a wide range of formats, formats that often vary from day to day and hour to hour. And so the unstructured data is really growing two times faster than the structured sources of data. So these are really the changing face of data, if you will, that is really creating an opportunity for organizations to capture that data, to analyze that data to great advantage.
So John and I particularly like this definition for machine data. There's several definitions out there, right, as you can imagine. But this one from Kurt Monish, I think, puts it very well, right? He says, machine data is data that was produced entirely by machines or data that is more about observing humans than recording their choices. So it's particularly that second clause that I find interesting, right? I think most people, when they think of machine data, they think of that first clause. Right, I can take sensors, the costs of sensors are dropping rapidly. I can now instrument something that's mechanical, things that spin or get hot or vibrate, and I can now get some data from that machine, and with that, I can get some insights to basically improve operational efficiencies of that machine. And we'll get into some use cases around that, and there's absolutely, tremendous opportunities associated with that. But the second clause, I think, is really interesting too, right? Because, when you think about big data analysis, a lot of people think about looking at, humans on the web, right? And we would not classify that as machine data or machine data type analysis, because a lot of what that's about is looking at the choices that humans are making, right? The decision to click on that banner ad, the decision to look at a certain set of product pages, a decision to put something in the checkout cart and click buy, right? Those are typically the types of use cases when you're looking at analyzing, say weblog data. But again, that's really more about human choices. But some machine data, and we'll give a few examples of it, are a result of things that humans do, but the real intent and opportunity is about their behavior, right? So just one example, right, would be, in healthcare, monitoring someone's heartbeat. People aren't machines, right, but you can certainly begin to collect that data, but it's not really a decision to beat your heart, right? It's an observation of that person's vitals at that point, and then you can glean some insights from that and take action.
Thanks, Chad. And as you say, we definitely agree on that definition. But let's look at some of the things that are really driving, as you said, the sensors that are collecting things that get hot or things that spin. And for that, we'll go to some analyst data, and we'll look at a couple different analysts here. If you look at, for example, something from Peter Middleton from Gartner, by 2020, component costs will have come down to the point that connectivity will become a standard feature even for processors costing less than $1. Now that has tremendous implications if you think about it. What that means is that the cost of putting a sensor that will collect the heat, the temperature, data about how a system operates, particularly a machine, will be so low that most things that we carry in our pocket or that are manufacturing or driving around or flying around or what have you will have a sensor of some kind on. They will be generating data. And of course that means that we'll have an opportunity. So if you look at the estimate from Bosch, they have 14 billion connected devices but by 2020, 2022. Cisco has an even more optimistic, I'd say, view of what that would be. And they'll say that there'll be 50 billion connected devices. So that's really the Internet of Things, that the machines that are talking directly to the Internet, that are communicating from machine to machine, collecting data, generating data out there, whether it's on manufacturing systems, as Chad said, or delivery systems, or whatever they happen to be. There's a tremendous amount of data. If you think, even if every one of those devices only created a couple pieces of of data, you're talking about hundreds of billions of pieces of data, and of course it's much more than that. Now it offers an opportunity. It offers an opportunity to the organizations that are creating those devices, that are creating the devices that are talking to the Internet. If you look at Gartner again, for them, they estimate there's a $309 billion revenue opportunity for the suppliers of devices that are smart devices, devices that connect automatically from machines and log their data. So there's a tremendous opportunity for the suppliers out there. And if you look at the overall economic impact, and if you expand beyond just the organizations that are supplying those devices, but to the impact of organizations that can take advantage of that, then you look at 1.9 trillion just from Internet of Things, the economic value add. So huge opportunity and add for the overall economies of organizations that, and for enterprises that can take advantage of that. So really a massive amount of value from the economic value. And then if you go even further, if you look on solutions just on top of those devices, so new services to users, the ability to avoid cost from downtime, to be more predictive and proactive, whether it's in maintenance or delivery or what have you, that is $7.1 trillion. Those are solutions on top of that data that's being created. So up and down the value chain around the Internet of Things, these machine-generated data, there's a tremendous economic value that we can look towards over the next, say, 5 to 7 years for organizations. And again, some of the examples we'll show you today are some of those forward-thinking, forward-leaning organizations who are already starting to take advantage of that data today. Now, in terms of the overall kind of requirements, if you're creating this much data, if there are this many devices, then really there are some requirements for managing and taking advantage of that Internet of Things data. One is you really need to have some very rich analytic applications that are able to take advantage of, read into, automatically process in a predictive and automated way that data. And it needs to be able to take data from a multitude of sources, right? Just not one sensor, but data that is integrating, or analytics and applications that are integrating data across a wide range of sources in order to get the broadest possible view and broadest and deepest level of analytics. Organizations also need to be agile. Right? If you're taking in real-time data and data that's coming off of things that are spinning in hot or delivery, then the organization itself has to be structured around being agile and the ability to react to, in many cases, automated ways, to the changes and to the signals that are coming in off of that data. Now, at the same time, you need to bring that into a single view so that there can be a human and a person who can help and analyze and kind of adjust the overall processes that are running within the organization. And what's going to happen is that data is going to give them some level of operational insight, right? They have to be able to take advantage of the changes in the data that are flowing in, the analytics that are going on through an operational insight that allows the organization to make changes to improve the experience of the customer, to take advantage or be proactive around the operations of the overall business. And ultimately the solution has to be enterprise ready, meaning it has to have the security and the governance in place, because you're collecting such a wide variety of data systems. You have to have that kind of enterprise ready capabilities built into that overall data platform and into the overall data systems that are going to collect and manage and analyze this data.
All right, so this is our last slide before John and I jump into 4 different case studies, some real-world case studies based on some joint client engagements that we've had, and we're going to cover in those 4 case studies the auto insurance industry, utilities, travel and transportation, and pharmaceutical manufacturing. But as you can see here, by no means is that an exhaustive list of what we're seeing occur out in the market in terms of industries either beginning their journey or already starting to realize some value from taking advantage of IoT and sensor data in terms of improving their business. And certainly if you are in an industry that we're not going to go into some level of depth in the next 4 case studies, I mean, feel free to, I mean, our websites have a wealth of information on them that are customized to different industries. And if you don't find what you're looking for there, and again, we have updates to these and new insights all the time, feel free to reach out to John or myself on LinkedIn or utilize our websites to contact folks in our organization, and certainly happy to go deeper in your particular verticals and industries. But as you're reading through these, I want to highlight just a couple real quickly. I had an opportunity within the last year to sit down with the chief data scientist at a very well-known oil and gas company. And what he was sharing with me around their opportunities around sensor data is right now they'll be very scientific around how they go about drilling for oil, right? Primarily based on a lot of great data around geology, right? And have incredible insights around sort of what to expect between the surface of the earth all the way down to the oil that they're looking to get. And they will use this data to create fairly robust models around different angles and turns as they're drilling down to the oil, and they'll even have planned out what types of drill bits they'll use at different points and what speeds in which they'll spin those drills. And what he was letting me know was that a huge opportunity is that even though they've got these great insights, they're still not perfect, right? They'll run into parts of the drilling process that were unexpected, that the geology data just didn't give them, or their mathematics just didn't quite sort of work out. And so since none of these plans are perfect, they lead to problems that are basically operational related that cost money, right? And so they're looking for any opportunity to get better at that process. And by putting sensors at the ends of the drill bits, they're now able to get in close to real time more information about what's going on at this particular point in the drilling process that will allow them to then make different decisions around, again, how fast they're turning the drill, or if that's exactly the right drill bit given the current conditions based on those sensor readings. Another one I'll call out on the far right there, gaming. It's a little near and dear to my heart since I joined Teradata a couple years ago, but prior to that I was on the practitioner side and led the data platform at a major gaming company. And how we'd use telemetry data, which is, again, in per Kurt's definition, a form of machine data, is when you're playing a video game, every time you press a button in a game to move to the right or move to the left, it can create a piece of data that can help analysts or game producers observe how people are interacting with these games. And so a couple of quick use cases on that. For a particular, like a role-playing game, one of the things we're able to do is look at how are people at a particular level progressing across a map. And occasionally you'd get these insights that would say, wow, there's 40% of this particular map with sets of game features that we spent a lot of time developing on that people aren't even going to, right? Why is that? What can the data tell us to allow us to fix that, to make it easier to find that or more enjoyable for people to want to go explore that, and basically create a better experience that really capitalizes all the investments that went into using that game. Same for things like sports titles, right, where the whole idea is to make the game as realistic as possible. And you can look at telematics to basically say, all right, people are shooting from all different quadrants of, say, a hockey rink. There's slap shots and wrist shots and goals made and goals missed. And how accurate and close to reality is the make-miss percentage for a particular shot type, for a particular coordinate on that rink, and then compare that with real NHL data, let's say, or Olympic data, and again make alterations to the game to make that even more realistic. So Again, the point that we really wanted to stress here is that we're seeing opportunities across a multitude of industries. The first one, as I mentioned, that we'll get into in some level of depth is the auto insurance industry. I'll start off with, for any of you that watched the Super Bowl this year, there was an ad that caught my attention because, I'm interested in this topic. It had Lindsay Lohan, a somewhat troubled celebrity, and she's pulls up to a school and knocks over a trash can and, is there to ostensibly pick up a kid, and the kid's like, well, you're not my mom, and she says, well, I'm sort of your mom. We're both 25 to 35 years old. We're both women on the go, and we both logged a lot of miles. And what I found interesting about this is when you look at auto insurance ads and typically the way they've competed in the past, it's really all been about price, right? Take 15 minutes, save $100, or the level of service, right? We're more comprehensive. We cover more things. We'll take care of your claim right away. And what we're starting to see is a value proposition emerge around companies saying that, hey, we are able to understand you better than anyone else, particularly what they're really getting at is your level of risk, and we will customize your policy to match you, not someone that kind of looks like you. And that's a really interesting, I think, value proposition as we go forward. So if you take a look at how the auto insurance industry has traditionally worked, and you could say this has been true for multiple decades now. And again, it's not a knock on the industry. In fact, I've got friends that have masters in mathematics and went through grueling actuarial exams. They have a lot of smart people, but they have been, as an industry, somewhat constrained on the types of data available for them to do risk analysis, right? So this whole industry is about assigning a level of risk and pricing policies based on, the market that you're serving, right? So if you overestimate, or let's start with underestimate, if you underestimate the level of risk on a particular policy, well, then your expenses will be too high and you won't be profitable. And if you overestimate the level of risk, well, people are going to get multiple quotes and you're going to be disadvantaged from a pricing standpoint. They'll go with someone else, right? So the key to the game is how do you get the most accurate level of risk assigned to a particular individual? So again, in the past, for decades, and suspect most people on this call are drivers and are somewhat familiar, at least with the kinds of data that go into assigning what your rates are for auto insurance. Certainly, something like the number of driving citations. Someone that gets speeding tickets is more risky. The more claims that you've made, right? If you get into auto accidents in the past, you're more likely to get into one in the future. I always love this question whenever I, get a new insurance policy. They'll ask this question: do you drive to work, and how far away is your office? And really what they're trying to get at there is, do you drive a lot, right? So if you answer that question, yeah, I drive this car to work and my commute is 20 miles, you're going to pay a higher rate than someone that says, no, I'm not driving this car to work, or I do drive it to work, but my office is only 2 miles away. They look at things like vehicle make and model, right? So, and particularly here, right, the more expensive the car, the more liable the insurance company would be, so they take that into account. Things like age, right? A younger driver is less experienced, so they're going to pay a higher rate. They look at credit score, as well as things like domicile, where you live. It's not, some parts of the country or world, you're going to have a higher accident rate or a higher vehicle theft rate or vandalism rate than other parts of the world. But now let's take a look at some of the new data that's now available. That doesn't mean that the data that was used in the past is obsolete, but that it is now becoming augmented with some of the new data that's available to further enhance setting these risk premiums. So continue to use the traditional, but now what you can do is install sensors within a car that are basically in very metered intervals, every second or 5 seconds, giving you a longitude and latitude of that particular vehicle. And with that, you can derive things like speed and direction. You can also look, so let's consider speed for example. If I overlay that with a map and I can now get how is this person behaving on a particular road. If the road is 55 miles per hour, how fast are they driving? Now, an initial reaction at this point is, people, particularly as consumers, are thinking, oh, I don't like this, right? Because if I go 60 in a 55, the auto insurance company is going to know this, and my rates are going to go up. But that's absolutely the wrong way of looking at it, right? The clients that we're working with are looking at this from a purely mathematical standpoint and saying, I'm not going to assume that going 60 in a 55 makes you more risky. What we want to do is, continue to build up our data and refine our models and look at a dependent variable like making a claim and then see what the independent variables were that led up to making that claim. So if it's, there are people that routinely do 60 or 65 in a 55 and that doesn't lead to a claim, that should not affect your rate, right? But if they determine that going 40 miles per hour in a 35 is actually very risky and does lead to claims, well, then that would be something that would be represented within the model. Same goes for things like acceleration and deceleration, right? So you might not ever get a speeding ticket for that, but if someone that they brakes hard, if that leads to accidents, then they now have these insights and can, again, incorporate that into their model. I was talking before about, the question, do you drive to work and how far? Other interesting questions that, again, they don't necessarily know the answers to yet, but they're working on getting these answers and incorporating them into their model is asking questions like, well, what's worse, someone that drives 50 miles a day but over the same route, or someone that drives 15 miles a day but in streets that are less familiar? Right? Now, you might have a hypothesis about it, but again, they're looking at the real data and the claims data and beginning to make those correlations. Same goes for weather, right? So, maybe doing 55 on a 55, technically you're not speeding, but if it's inclement weather, perhaps that's really risky driving behavior. And, at what point and what speed should you drive given certain weather conditions to be the safest driver possible? And so the benefits of being able to do this are really twofold. One is much more accurate, hyper-accurate risk premium setting, because you know the customer so well, exactly what their level of risk is, and you can hone in on very fine-grained pricing for them versus some higher-level segmentation. The other huge benefit, and I love that they're looking at it this way, is how do we make safer drivers, right? It's in everyone's interest, including the insurance companies, to have fewer accidents. And so they can take this data and share it back to customers in a way that's not like sort of crude and ham-handed, like don't speed or things like that, but really let them know that, hey, the biggest thing you can do to improve your safety and lower your premiums is there's a particular street in your neighborhood that you're going 5 miles per hour over the speed limit on. If there's one thing that I could change about your behavior, that would be the thing, that we'd seek to change, and that's, again, going to save you money and hopefully save your life. From a deployment perspective, they are ingesting this vehicle telematics data into the Hortonworks HDP platform. They've got multiple formats of this data depending on the telematic provider. They go through a process of standardizing that format. They overlay it with NavTech, which is map technology that gives you the speed limit on different roads. They also pull in VIN data from the web, right? So I know what kind of car it is, things like that. And then basically what they're doing is they're sessionizing that into a trip file, and sessionizing, just like you might see someone sessionize someone's experience on the web, right, that shows start to finish, how did they enter our website, what did they do, how did it conclude. they'll create trip files to that effect, and they can do a lot of analytics on that utilizing Hive and other types of analytical tools. And then as they really develop what those key signals are that connote risky behavior, pull those key signals into their Teradata data warehouse and have that integrated with some of the other data around their speeding tickets and their domicile and their policy information, and begin to continue to refine and communicate with those customers regarding that relationship. John?
Yep. Thanks, Chad. And I recently rented a car in Europe, and I noticed that it actually displays the current speed limit on the digital display of the speedometer. So more and more digital data being integrated together there on the car. I'm sure it'll go into the insurance as well. I'd like to switch now to talk about an electric utility use case. And this is quite interesting. This is a very large, one of the largest electricity providers in Europe. And one of the use case here is effectively smart meter and sensor data. And just as kind of a background for energy companies, once they split the atom, right, if it's a nuclear provider, or once they burn the coal or the oil, there's no way to put that energy back. Although I think Tesla is trying to change that, but there's no big battery to store that. So it's a challenge for them to make sure that they match the amount of energy produced to the amount of energy consumed. And they're always trying to optimize that because, if they produce too much energy, then there's waste. If they produce not enough energy, then there's strains in the systems and brownouts and all kinds of problems. So the goal is really to make sure that they match those curves. And one of the things that they use to do that, of course, is metering. Now, the original meters that were used that everybody was mostly familiar with on their house were a meter where somebody would come by once a month to read that data. And that really gave 12 points of data per year. And if you think about it, that's not a lot of information. It basically tells you how much energy was used by that household in the past month. It's a pretty simple metric for understanding exactly that household. Of course, there's so many different kinds of households, so many different ways that the data are being consumed, and so it's not really enough of a picture for this energy company to really do a better job of mapping the consumption to the production. Well, enter, of course, what are smart meters. Smart meters record, and there's different kinds and different types, of course, but a common smart meter, and the one used in this case, recorded 5 different kinds of measurements 4 times every 4 hours for each household that's connected to that smart grid. So it's providing information like what's the peak usage in this in this 4-hour period, what's the minimum usage within this period, what's the rate of change. All these different components of the data are now collected. Which is fantastic, but what that means is there's a huge increase, 100x gain in the amount of data that's being collected on a per household basis. So tremendous amount of new kinds of data. Now this is really an opportunity for this energy company for them to really map and measure the data and make sure that they can correlate the production to the overall usage of the data. And what that really requires in this case was for them to create an entire ecosystem, a telematics ecosystem where they're collecting all of that data. It actually uses cell phone networks to collect the data wirelessly, transfers that data back to a centralized vendor who they contract with in order to collect all of that data. They also bring in data from external providers. So this is where we go back to the original kind of requirements for an overall telematics system in order to an IoT system to produce and process and consume multiple formats of data, ultimately pushing that into one of their business centers. So they're really pulling off data from the web. They're pulling data from the weather systems. They're providing and collecting data from the smart meter systems, also that they can kind of correlate all of this data together in order to provide it through to their business users who are constantly analyzing the data and looking for opportunities to optimize and provide also new services, as well as to be more predictive and proactive for their field and maintenance systems so that they can understand where might we see a problem, where are there spikes, where's the data clean, where's the energy that's being delivered to the house clean, or where are we starting to see kind of signals in the data that are indicating that there might be a problem with a transformer or something that's bringing the data to, or bringing the electricity to the house. So, there's an entire ecosystem that starts to rely on the collection of the data, the processing of the data. Now, what that means is for this energy company, they're able to go and provide new kinds of analytics, both new kinds of analytics internally to do a better job of demand planning, to look at the energy consumption, to look at weather forecasts, even down to a kind of microclimate, microgeography level, so that they can do planning down at a very fine-grained level. They can also do a better job of fraud protection, because they can look at and understand, okay, what is the consumption? Is there something where we are producing energy, but we don't see that energy being consumed by one of our, houses that are on the smart grid? So it also helps them with kind of theft of services and theft of the energy. And it also helps them integrate with things like building automation systems, right? Automated HVAC systems, which turn the lights on and off, and control the temperature and humidity of large office buildings and things like that. So integrating all this data gives them new kinds of analytics that help them do a much better job. Now, the benefits, of course, are they can do a much better job of preventing outages. They can monitor their overall grid that they are producing the electricity to. And of course, even on things like CO2 emissions, these energy companies pay, in many cases, taxes, carbon taxes, or carbon credits they have to purchase related to the amount of energy they're producing because they're burning coal. This helps them optimize those emissions and optimize the spend that they have in those areas, and as well across a range of other services and analytics that they can do around the delivery of the energy to their customers. Ultimately, this also enables them to provide additional added services through to the customers, right to the end consumer. So they can actually send an alert to their users via text or via email or what have you that says, hey, you are using a maximum amount of energy, or you've seen a significant increase. This is, of course, going to impact your bill. So even just with this can result in a behavioral change. What this organization found was these emails, by making a consumer aware of the spike in consumption, even that has an improvement on how people think about and use and utilize energy. They'll be more conscientious around turning lights off and controlling the temperature within their house. So these are new kind of value-added services that actually help the overall power generation, just help the overall environment altogether. And if we were to look at what a reference architecture looks like, again, collecting this into a large Hadoop cluster from all those different streaming services that sit in the backside of that kind of telematics or IoT ecosystem, collecting data from streaming sources, from the smart meters, collecting data from the external sources, but providing end users with smart access, different ways that they might go and analyze the data, whether they're data scientists or data users who are using SQL-like interfaces, but collecting that in a kind of a large data lake-like implementation in order to provide the additional services and enhance the way that they're delivering the energy out to their consumers, and ultimately making that better for everybody. Chad?
All right, great. So in this next case study that we're going to share with you around travel and transportation, one of the things I just want to note up front that, if you look at the last two case studies that we shared with you, and hopefully found them as interesting as John and I did when we first learned about them, they can be initiatives that, they do take a while, right? In the case of what John just talked about, right, you've got to go out and you've got to put these meters on the different homes, and there's a lot of capital expenditure just associated with that. We're still not there in terms of every car in the United States having telematics sensors in them. I mean, you're certainly seeing the start of these industries that have been around a long time and haven't changed, beginning to change for the better and take advantage of this technology. But we're seeing cases where companies can get value right away from things driven by, not the CEO, but people down at the line that spot a great opportunity and are applying this technology to use that to get some very near-term wins. And so one of those that I want to share with you in travel and transportation is something that with a client that we had that was really only a couple-week engagement. It was a POC that really led to some very interesting and from their perspective, game-changing results. So it has to do, we call this POC the hanger bearing, right? And you don't have to be a mechanical engineer to understand this case study. All you need to know about what a hanger bearing is it's something that's in an aircraft that can fail, right? And things that can fail, particularly in something like an aircraft, you need to really pay attention to that, right? And so you need to do maintenance on them. A lot of times you're doing preventative maintenance. And again, when you're in an industry like this, there's not only the safety concerns of it, but there's also, getting it right in terms of, when you take a particular aircraft out of the rotation, there's a significant opportunity costs associated with that. So you want to be as smart as you can be. So this particular team said, we could pick anything that fails or that we do maintenance on. Let's just start with one, right? So they picked this hanger bearing thing. And the questions that they asked themselves and that they were looking for answers for was, what are some of the common event paths that lead to the hanger bearing failing? And what are some of the factors that contribute to that failure over time? And what events can be investigated to identify and prevent these failures? Because if you know the answers to those questions, then you can do a much better job at doing preventative maintenance on that particular mechanical item. So first thing I want to share with you here is just, again, to the point around how quickly some of these insights can be discovered and acted upon. A lot of our joint customers with Teradata and Hortonworks are also using some technology called Aster Data, and you're seeing the code from that too. It's SQL, ANSI SQL, but highlighted in red there is a MapReduce function. And Aster's got hundreds of different MapReduce functions. In this particular case, it's using something called NPath. And I think one of the most exciting things going on right now in this world of big data, particularly when you compare it to the tools that we've worked with in the past. I've been doing data warehousing for like 20 years now. When we only had one technology like a relational database, while we were able to do some very powerful and sophisticated analytics, there were certain types of analytics that just did not perform well, even in a parallelized environment like Teradata. Things that are procedural in nature, things like time series, graph, even things like text analytics, where you're comparing one element to another element in the table. There's, again, just too many round trips if you're working with relational technology, but with the compute framework, with Hadoop and things like Aster, you can now very efficiently parallelize these new types of analytics. So, again, you can see very easy to write, very short, and basically what this SQL statement's saying is I want to hone in on this hanger bearing thing, and I want to see what events lead up to it failing. And we can produce a visual like this. This is a Sankey graph, right? And quickly get some insights based on what that simple bit of code produced. And one of the first insights is that the hanger bearing on the left side of the aircraft is failing more frequently than on the right side. And that was actually an insight they took to the designers of this particular aircraft. So, that shouldn't be, right? Maybe there's something with weight distribution or whatever. You guys go off and take a look at that. But we do have, this aircraft as designed in our rotation. So what are some of the events that are leading up to that failure, even though it's occurring more prominently on one side of the aircraft than the other? And some of the things that jumped out is a much higher than expected weight on wheels and weight off wheels that led up to that vibration being much higher, as well as an insight around the left and right engine temperature as being contributors to the excessive vibration, which then led to the ultimate failure of that particular hanger bearing. And then they could quickly iterate on that analysis. So here again, they go back to the code, and now they're basically just a couple modifications and say, I want to look from 900 seconds after that vibration occurred and see what other parametric type events occurred as a result of the excessive vibration. And again, without getting into all the details here, the key net is that they found 5 other things of concern when the hanger bearing vibrates excessively. So how did they take action on this? Well, again, here's sort of how they deployed this environment. They're collecting all this aircraft sensor data. There at the bottom, that gets ingested into the Hortonworks HDP platform. They'll pull it into what I was mentioning earlier, the Aster Discovery platform, where they can use SQL and these pre-built MapReduce functions to develop these models, not just for hanger bearing, but for a variety of different parts that might fail. They build these predictive models. They instantiate those within their Teradata environment that has a wealth of other data that's not just related to the sensor data, right? It could be, how old the aircraft is, what maintenance has been done on the past, how many hours has it been since this aircraft was last serviced or that particular part was last serviced. And now that they know what events to look for, right, the out-of-deviation sensor readings, they can either pull those into their IDW, or they could even bidirectionally just push that processing down right into Hortonworks, HDP, and Hadoop there to utilize that data on the fly. And now they've got much more sophisticated and accurate models that allow them to now schedule when to pull an aircraft out of the rotation and do maintenance on various parts. John?
Thanks, Chad. So that's right. Thanks. So let me talk now about a pharmaceutical manufacturing use case. Very, very similar in some of the ways that there are lots of data sources being generated here. In this case, this is one of the largest pharmaceutical manufacturing companies in the world. And in their case, they had a problem where, and this is, I think, common amongst many different pharmaceutical companies, creating vaccines and manufacturing vaccines is very, very expensive. And the yield that they get, they're always trying to maximize the yield that comes off of the manufacturing process. And it turns out that, for every 3 batches of vaccines that they produce, roughly 1 of those is usable. So they're always trying to optimize and improve that manufacturing process to look for what they would call their golden use case, because there are so many variables in the manufacturing process. So in this case, you're talking about literally having to discard unusable vaccines, even if they, when they fail one of many different cases, or if they're not produced in exactly the right way. And it's such a complex process with so many factors that this is one of the ones where Hadoop was really a natural kind of solution for processing these varying types of data at the large volume. And in this case, the system that was in place, the analytic process that was in place, was really a spreadsheet-based system, which had limitations in terms of the size and scale of the data that was being collected. So, firstly, just a little bit of the kind of background on what it takes for vaccine production. There are many different machines. It's a multi-step process, and again, where each system, each step in the production process involves major pieces of equipment which are processing the various components that go into the vaccine in different ways. They all are measuring and monitoring the speed and rate and collecting data from that process. Also, in terms of the data around the rooms that they're being processed in, so the temperature, air quality, air density, humidity, how often these machines were cleaned. There are so many different factors that are in and impact the production process, in addition to just the process itself and the multiple steps that the vaccine goes through in terms of production, that looking at and understanding what are the root causes, what are the key variables that are impacting the overall process are very, very difficult to determine. So in this case, there were multiple data sources being ingested into their Hadoop platform across a varying range, literally hundreds of variables. Again, some of those, they were originally being ingested into a spreadsheet, which was very limiting in terms of their ability to process, and they were in fact only able to look at and analyze a single run, a single production of the vaccine. And of course, this really hindered the process of looking across multiple runs, looking for correlated variables across a large number of production runs. Now, using Hadoop, what this manufacturer was able to do, this pharmaceutical company, they were able to put all of the data from all of the runs for a particular vaccine into Hadoop. So they were really able to correlate the maximum amount of data that they had available, which gave them really some what I'd call, what they would call even life-saving results. And it's life-saving in that they're able to crunch a huge amount of data to find the appropriate root causes in order to create the best possible yield that they could out of that vaccine. And what that means is, by creating a better yield, they're able to lower the cost of the vaccine that they are bringing to the market. Better, faster ability to identify the yield gives them that ability to lower the cost or improve their yield, gives them the ability to lower that cost, offering and passing that on to onto the consumer, increasing the supply of this. So literally can have substantial life-saving impact by being able to process all of this data. In this case, more than 15 billion calculations across 5.5 million, batch-to-batch comparisons. They're able to look across all of the data for this particular vaccine. Now, the way that they did that was they loaded everything into what they called a data science platform. So taking all of those variables, providing that access for the end users, data scientists teamed with the scientists that they had in the organization to analyze all that data, crunch huge amounts of data to find the correlation. And in this case, they were able to find the key variables in this vaccine. And now this data science platform is being expanded to all of the different vaccines. So they didn't start with a single vaccine in the kind of the test case of this single vaccine, literally saving tens of millions of dollars in the production process, and now they're expanding that out to more of the platforms they have. So with that, I want to thank you very much for attending. Hopefully you found these interesting, and hopefully we have some questions built up for Chad and myself.
Yeah, John, Chad, thank you so much for such an excellent presentation, and there was so much to cover. We do have a number of questions from the audience, and I want to get started with today's Q&A. And I want to thank the audience for their participation. We have a lot of questions, and we'll do our best to get through them. During this Q&A session, I'll leave this screen up, which has contact information for Chad and John, should you wish to contact them directly during the period after the webinar today. So our first question, you've talked a lot about sensor data, which I think of our audience thinks of as numeric. What about video and voice and other types of data?
Yeah, I'll take that too, or I'll start, John. One of the things, it's a case study that we didn't include in this, but I find particularly interesting. It's also related to insurance, where, again, one of the decisions that they have to make on a routine basis is what claims to investigate and which to not investigate, right? And one of the things that they are beginning to realize some success in is, and again, this is something that's completely now possible as a result of technologies like Hadoop that really didn't exist in the past, but to look at the voice recordings when someone calls in and makes a claim, and basically try to identify, based on that person's tone of voice, if they're lying or not, right? And so that as one input in conjunction with other kinds of structured data, like, have they made repeated claims before? What is our liability for this claim if we pay it? Beginning to use that data to basically prioritize which to investigate and which not. And they're starting to see some lift from that.
Yep, Chad, and I would add that, Not just the video, but even just still images. I know, on many insurance companies, for example, just to stick with that theme, you can now send in your images, but they can do image processing to evaluate those images and kind of correlate that to as you said, the claims around the severity of the accident, and make sure that there's a correlation there.
John, Chad, thanks for those excellent answers. Some of our viewers have been wondering about security issues around using these sensors, whether or not they can be spoofed, how they might self-authenticate. What sort of issues have you seen in the use of these sensors around security?
Yeah, I'll take the first stab at it. In some cases, you're going to have data that's much less sensitive, right? That's publicly available data, or again, right, it's some data that's being collected off a machine. There's no real privacy concerns or things like that in certain use cases. In others, and quite honestly, right, it is an issue that's being worked through. Again, I'll go back to say the auto insurance, right? People are a bit concerned about people being able to see where they've driven and how long they've been at a particular place. And so there, point to, and where we're working with our clients quite a bit is really hardening and securing that environment. Encrypting is necessary, and we're starting to see certainly a lot of advances in terms of the security protocols around these environments to prevent that.
Yeah. Oh, great answer. Thank you. Now, if you are a member of a company that's not yet involved in using sensor data or IoT, what is kind of the minimum entry requirement? A NoSQL database, an analytic platform. What would you advise customers for their minimum requirements to get started?
Yeah, Chad, I'll start with that one. I think and it's an excellent question. You don't have to have streaming sensor data in order to get started with with this kind of system. You can start with just a couple of servers. It can be a Hadoop-based platform like the Hortonworks data platform or other open source systems, to just really get started to get yourself familiar with the tools that are available to process the data, to capture even just a small amount of data. We see companies starting with even just hundreds of megabytes of data, if not terabytes of data. So you don't have to have a huge amount of data. Really, it's just you can actually start small and experiment and expand on the use cases once you start to understand and are familiar with the technology.
Yeah, to add to that, again, as John's calling out, the barriers to entry are very low, right, from a technology standpoint. And then, I think the question becomes, like, when you get started, right, there's this, do I need to have a well thought out and formulated strategy to justify this, or should I just start collecting some data and playing with it? And I know the right answer is, and the advice I should be giving everyone, have a well thought out strategy. We certainly talk with our clients about that they're looking to really ensure that they're going to be in the right place with their big data strategy a couple of years down the road. But like the example I shared with hanger bearing, we're repeatedly seeing people say, like, let's just do an experimentation project, a POC, spin something out for a couple months. This is data that we're not that familiar with yet as an organization. It's very unknown to us. We're not really sure how to use it. And we've seen many examples where people get this breakthrough initial insight even in a POC phase. So I'd certainly encourage people to investigate that route as well versus a very lengthy strategy session, right, that might consume, multiple months or years.
Okay. Well, hey, Chad, John, thank you both for great answers to some very good questions. For those of you who have asked questions that weren't answered today, we'll be sending all the unanswered questions to Chad and John and the teams at Teradata and Hortonworks so that they can follow up with you after today's webinar. I have just a couple of brief announcements before we wrap up today. Whoops. Let's try this. There we go. Please mark your calendars for July 7th, which is our next data science webinar, which will be Faster Predictive Insight with Data Blending, sponsored by Alteryx. Also, please remember that today's taping will be available for your on-demand viewing later today and can be found on the home page of Data Science Central in the webinar tab located at the top of the page. So this brings today's webinar to a close. And I'd like to thank our audience for their attendance and their thoughtful questions, and a special thanks again to Hortonworks and Teradata for their sponsorship, and our speakers today, Chad Meley and John Kreisa, for their insight on today's topic. My name is Bill Voorhees. I'm very pleased to have been your host for today's event, and I look forward to seeing you all again on July 7th. Have a great day.